Hello, I'm Bukola Joseph, the physics enthusiast. You are welcome to my channel. So we're going to be solving a problem on statistical physics, okay? Advanced statistical physics to be precise, okay? So I'll read the question from my manuscript. The question is on the board for you to see. So let me read the question. It says, evaluate Lagrangian undetermined multiplier better. Okay, so we are going to be solving this problem, and of course we are going to be solving this problem using the kinetic theory. We're going to be using the Maxwell-Boltzmann statistics, and I think we're going to be using this formula number for number of assembly. We're also going to be using what again are we going to be using? Okay, let's do this. Yeah. So, to solve this problem, okay, let me come to this side. Okay, from kinetic theory, okay, so we have from kinetic theory, okay, from kinetic theory, we know that mean energy E is equal to 3 all over 2 kT. So we're going to call this equation 1, okay. So now, for energy of assembly, we are going to say for energy of assembly, we have E is equal to sigma G Ng Eg. Okay. Now for number of system, that's N. For number of what system? Number of system, N. Okay, we say N is equal to sigma Ng. Now for us to find the mean energy, it's going to be E is equal to, this is not supposed to be here. E, the mean energy is equal to E all over what? N. Okay, so this is equation 2. Let's call this equation 3. So we have mean energy to be this over this. So let's do this. So it means this will be what? Sigma J Nj Ej. Let me write my E well. Ej all over this sigma J Nj. But from Maxwell-Boltzmann statistics, from Maxwell-Boltzmann, I don't know if you still remember this principle from Maxwell-Boltzmann. This is the spelling, okay? From Maxwell-Boltzmann statistics, so I'm going to be abbreviating this, okay? So from MB statistics, from MB statistics, okay, we have Ng is equal to B, is that it? Nj is equal to Gj exponential alpha exponential BEI. Okay, so we are going to be substituting this Ng into this equation 4. We'll substitute it into this equation 4. Okay, if we substitute it into equation 4, we are going to have this. Let me just clean equation 4 and put equal to by the side, right? So this is what is going to be. Okay, so we have sigma J. Remember we're substituting Ng, so it becomes Gj exponential this exponential BEI, right? There's Ej here, so we're going to put Ej, okay, all over Ej sigma J. We are substituting Ng with this, so we have Gj exponential BEI. Let me write this E very well. Okay, so what next? What next? So we are going to cancel out EJ. I mean exponential alpha. We'll cancel it out, and then we'll be left with the rest. But GJ, okay, just notice that GJ is equal to, I don't know if you are seeing what I'm doing on this side. Don't know why my marker is trying to disappoint me. Let me see it so that you can see. So we have GJ is equal to B the tall, which is equal to BV. This is equal to BV 2 pi, right? 2m raised to power 3 over 2 e raised to power half dE. This is GJ. Okay, this is GJ. So we are going to be substituting GJ into what we have here. Okay, so I don't know, I don't think we need this information, so I'll wipe this. I'll wipe it. Okay, so we'll substitute this into this equation. So if we do that, we'll have this is equal to sigma J. Remember, we're substituting GJ with everything here. So it becomes BV 2 pi 2m 3 over 2 E half dE. Okay, so remember there's E. Yeah, we have exponential BEI EJ. Okay, we only substituted this. All right, all over. Okay, so now this substitution of this would allow this sigma to be changed to integral. Okay, because of this substitution we are doing, this sigma will change to what? Integral. So we have this now. So we have the integral of this. Okay, this EJ, GJ, we are substituting it to be what? BV 2 pi 2m 3 over 2 E half dE. Okay, GJ, and then we have exponential BEI. Okay, so what we have here, from what we have here, BV will cancel BV, 2 pi will cancel 2 pi, 2m this raised to power 3 over 2 will cancel 2m raised to power 3, and then we are left with this. Okay, so if we are left with this, it means this becomes this. So integral e raised to power half. Okay, so mind you, if E is equal to EJ, let's say E is equal to EJ, we can say E half, okay, exponential BEI. If E is equal to EI, then we have E dE. 1 2 3 4 1 2 3 4. So we have E half, then E. So if you combine this E together, you know this is raised to power 1. We have E raised to power 1 plus 1 over 2. Okay, if you do your LCM, this becomes 3 over 2. That's if you do LCM, using LCM, you get raised to power. So we'll sum this with this, it becomes E 3 all over what? 2. Okay, so I can bring this one down like this. Okay, all over the integral 0 to infinity. We're left with this. Let's arrange it. E1 over 2 exponential. Remember we said EI is equal to E. So we have exponential BE, E half, exponential BE, then we have DE. So at this junction, we are going to be integrating the numerator. Okay, considering the fact that beta is a negative function. Okay, so we are going to be integrating the numerator. So integrating this, we have, if we integrate the numerator, that's this 3 over 2 exponential be de. We have minus 3 all over 2 beta. This integration is something I will show you in the next video. I'll be doing the integration, how they got to this point. Okay, but this is it, is equal to this, the integral, this of exponential be de. Okay, so we are going to be substituting this information to replace what we have on the numerator. So if we do this, let me sit down so that you can see what I'm doing. So if we substitute this to the numerator, this becomes, let me wipe this information so that it will be clear. This becomes what? Minus 3 over 2 beta, the integral of 0 to infinity e half e be de, all over, okay, this, we have integral to infinity e half be de. Take note of this. After the integration, this other side becomes equal to what you have on the denominator. Okay, so just for you to remember in case you are faced with this kind of problem. Okay, but I'm going to be doing the integration maybe in the next video. So this is what we have. Now we will simplify now. So from what we have, this we cancel this, and then we'll be left with what? E is equal to what? Minus 3 2 beta. Okay, this is what we are left with. But remember the first equation we have. Okay, E is equal to what? The mean energy from kinetic theory. The mean energy from kinetic theory is equal to 3 over 2 kt. So we're going to be substituting this. We have 3 all over 2 what? Kt is equal to minus 3 all over 2 beta. Okay, I don't know if this beta is supposed to be up or down. So if we multiply both sides by 2 over 3, so that to simplify, we'll multiply both sides by 2 over 3. So if we multiply this side by 2 over 3, we'll multiply this side by 2 over 3. 3 we cancel 3, 2 we cancel 2, 2 we cancel 2, 3 we cancel 3, and then on this side we'll be left with what? Kt is equal to minus 1 over beta. Okay, remember we want to make beta. What is beta we're looking for? So we have to make beta the subject of the formula. How do we do this? Okay, let's just do cross multiplication. If we cross multiply, we have beta kt beta is equal to minus 1. So we divide both sides by kt. We divide both sides by what? Kt. Kt we cancel kt, right? And then we'll be left with what? Beta is equal to what? Minus 1 over what? Kt. And this is the final answer. This is the final answer. So this is the Lagrangian undetermined multiplier. So this is the Lagrangian undetermined multiplier. If you enjoyed today's problem solving, please subscribe, please share, like, comment. I'm still Bukola Joseph, the physics enthusiast. Bye.